Good morning. Could you comment your names in the chat so I can do a register? So today we're going to continue working through this practice paper. I think I said to you guys to try and get 5 and 6 done for today at home. So we're going to start by just going through these as soon as I've got this register done. Yeah, so please comment some names. Cool. Hey, Callum. Becca and Fifi. Hello, everybody. Alex, Caleb, and George. Anybody else yet? Cool, we'll leave it for now. I'll come back to the register later. Okay, so next question here then is our first probability question. We're trying to find the probability it is not E given it is not F, and we've got a few bits and pieces here. What I would suggest doing is drawing a Venn diagram. It just means things will be slightly easier to remember and to visualize as well. Hello, Joanne, I think that is, isn't it? Yep. Cool. So we're going to try and turn this information into a Venn diagram, and I'm going to put it right here. So we've got event E and event F. We know the whole of the E circle is 0.25, the whole of the F circle is 0.4, and we know the middle is 0.12. So I can start filling bits in. This is going to be 0.12. It's not really working, is it? Let's just redraw the middle of the Venn diagram. There we go. So 0.12. And the rest of the E circle is going to be 0.25 take 0.12, so it's going to be 0.13. And the F circle is 0.4 take 0.12 gives me 0.28. So with the middle bits filled out, we can find the outside bit, which will be the inside will be 0.4 plus, so that the inside will be 0.53, so the outside is going to be 0.47. Cool. Good morning, Roddy. I think we've got some hay fever on the way, which is great. All right. So yeah, there's our completed Venn diagram. So we're trying to find the probability it's not E given it's not F. So we need the probability. If we use the equation, this is going to be the probability of not E and not F. Yeah. Not E and not F divided by the probability of not F. Thanks, Caleb. Okay, so not F, if we look at our Venn diagram, is everything outside the F circle. In other words, it's going to be 0.6. And not E and not F is going to be 0.47, which is the outside of the circle. So if we type this into a calculator, we should get an answer of what will it be? 0.783. Morning, Charlie. Try and arrive on time next time. Right, okay, cool. So that's part A done. Explain, showing working, whether or not they are independent. Okay, so there's a couple of ways we can test for independence. I'd say the main way is to use probability A and B is probability of A times probability of B. And we can do that just looking at the bits they've given us. So if that's true, they are independent. So if we do the test, 0.25 times 0.4, does that equal 0.12? So I don't think it's gonna, but 0.25 times 0.4 gives us 0.1. And we can say 0.1 is not equal to 0.12. Therefore, not independent. Okay. So what we got next? The event G has probability of G happening 0.15. E and G are mutually exclusive, and F and G are independent. Confusing. Okay, so it wants us to do a Venn diagram. So luckily, I've already started a Venn diagram. So we're going to add G over here. So let's alter this one. Such a lovely circular Venn diagram. So there's F and there's G. So the whole of F we worked out earlier was, what was it? 0.28 goes in here somewhere. And we're told the probability of G is 0.15. So the whole of the G circle is 0.15. But it's going to be using some of that 0.28 as well. Okay, so they are independent. So we know that probability of G times the probability of F should be probability of F in G. So really we're using what we've literally just used in the last part of the question. So the total probability of G is 0.15. Total probability of F was 0.4. That should equal the bit in the middle. So if we do that on a calculator, we get 0.06. So the middle bit there, 0.06, which means that the rest of G is going to be 0.09, and the rest of F here is going to be 0.1. No, is that right? No. 0.22. That should all add up. Cool. And then all I need to do is put a box around it. And fill in the outside region, which this time will be uh, 0.38 on the outside. Cool, so that should be your correct and finished Venn diagram. Okay, the reason there's no overlap between E and G is because E and G are mutually exclusive, so there's no chance of both of them happening. So we draw them kind of separated on the Venn diagram. Right, let's make some space here for the last bits. Last bit. Find the probability it's not F or G. So we need to find the probability it's F or G and then take that away from 1. So F or G is going to be all of those probabilities I've just circled. So if I add all those together and take that away from 1, basically the region that we want is going to be this bit. If it's not F or G, it's going to be those two bits added together. So we'll get 0. Will that be for 0.51 is our probability of not F or G. I forgot the E thing outside the top right. What do you mean? What have I done? Um, Callum, if you could specify what you mean by that, that'd be good. Oh, the little oh yeah, the sample space logo. Sample space logo. Yeah, I've never bothered with that one. It's maybe with the thinner pen would be good. Yeah, well spotted. I really can't draw this. This is why I try and never bother with it. Whatever. Squiggle, put a little squiggle in the corner. That's fine. And that's just to say that that is the sample space. So include that in there. Get rid of that. Fixed it. Cool. Thank you. Well spotted, guys. All right. We're going to move on to question 6, which is a little bit shorter. So if I get rid of all this, do you actually need it? I draw. Let me check. I don't believe you do, but let's make sure before I tell you that. Where can I find this information? It'll be in last year's paper, won't it? Um, just checking now, guys. I won't be too much longer. So we got applied. I can't find it right now. Let's ignore it for now. I'll check later when you guys are doing something on your own. So all right, we'll go through 6. I know you didn't used to need it, but I haven't actually checked whether you need it in the new syllabus. So it's something I will check in a second. Okay, in town, 54% of the residents are female and 46 are male. A random sample of 200 is taken. Using a suitable approximation, find the probability that more than half of the sample are female. So, any ideas how we're going to do this one? It's quite a tricky one, this one. Binomial, yeah. Well, to start with, yeah. And what does it mean by a suitable approximation? Normal approximation, yes. We're using a normal approximation to the binomial distribution. So, we'll say x is a binomial, and we've got a sample of 200 residents. We want the probability that more than half the sample are female, so probability being female 0.54. So that would be our binomial thing. We need to turn this into a normal distribution. So we're going to use the equations, what is it again? Mu equals np, and sigma equals the square root of 1 minus. Let me get this right. Is it p 1 minus np? I feel like it is. I think that's right. I only taught this last week, but I believe that is it. Okay, so what we do next is look at the... It's NP 1 minus P. Sorry guys. Cool, that is all good. Yes, NP because it's mu. Alright, so we need to change that into a normal distribution, so we work out what mu and sigma are. So we're going to do n times p to get 108. And sigma is going to be 108 times by 0.46 and then square rooted. So you should get sigma is 7.048. No root, really? No, I think there is a root. I'm in fact sure of it. We're finding sigma, not variance. Okay. And then we're going to put this into our normal distribution. So we're going to use y for the normal with 108 and sigma squared. Maybe that's what you meant, Joan. No, was that Joan? No, that's George. No root. Yeah, but we're finding sigma. Yeah, that's right. But I would always find sigma and then put sigma in, because sigma's and then right squared rather than right the variance. Cool. All right, so we want to find the probability that more than half of the sample are female. So half the sample is going to be 200. So we want to find the probability that y is greater than 200. But because it's a normal approximation, we need to do a continuity correction. So if you remember how we do that, you think about a binomial. We want more than 200. So we actually want, on normal distribution, more than 200.5. Yep, 100. Yep, I'm talking a load of rubbish today. 100 and 100. So you actually want to do 100.5. Thank you, guys. So we continuity correct this and make it 100.5. And get out the calculator, bash it in. So if I bring up the old calculator, and we're going to go to stats, normal distribution, standard normal, lower 100.5, upper, well, goes up to 200, but we're using normal, so let's just go up to something big. Sigma 7.048 and mu is going to be 108. Cool. Let's draw it, have a look at things. Cool. So we should get a probability as 0.8563. Just slightly different to what they've got in the mark scheme. I think it's because actually we only want to go up to 200.5. Because you want to include all 200 people. I reckon that's going to have a difference. A very slight one, albeit, but I think it will. No, that's weird. Because it tells you to approximate it. you wouldn't be approximating it, you'd be just doing a binomial if you did it that way. See, my answer is slightly different to the mark scheme. I think that's because we've done it slightly more precisely, but I think they rounded their sigma, so yes, but we can do it like that. So we get 0.856. Fifi, why is it 100.5? Check out my sketch here. Does that kind of make sense? Because if it's a binomial, we want to... Oops. If it was a binomial, which you started off like that, we would be wanting to find this area here. If we just put 100 into our normal, we're going to lose... We'll have this bar here extra, like half of this bar. We don't want this bar, so we're going to go from 100.5. Sorry, guys. To answer Fifi's question first, then, why is it 100.5? Because if we just did 100, we would include half of the 100 bar as well. We don't want that though. We want it to be greater than 100 from our original binomial distribution. So normally we're going to go from 100.5. And to answer George's question, why can't we just use the binomial? Well, normally we would, but it tells us to use a suitable approximation. And that is key for use the normal to approximate the binomial. Everybody all right with that? Yeah, I'm gonna move on. Cool. Oh, that's as far as I pasted. Okay. Is it this one? Yes. Right, so that's all of the stats bit done. Is it Caleb's birthday? Happy birthday, Caleb, if that's true. Right, so. Oh, this looks horrible, doesn't it? We got two identical seesaws joined at their ends, as you would. That makes perfect sense. Why not just describe it as something else on two pivots? Can we hear a song for Jenny? Ah, no, that's one of my band songs. Yeah, doesn't matter. Anyway, she's my girlfriend. She's might be playing some keyboards. Not that it's any of your business, but there we go. So, two seesaws are joined at their ends. Robert in the middle weighs 80, standing on top of the joint of the two seesaws. That seems like a dodgy place to stand, but there we go. The distance between Robert and each pivot is 2 meters. Poppy and Quentin stand on the two remaining ends of the seesaws. Poppy weighs P, Quentin weighs Q. System is in equilibrium. Lovely. What a horrible question. Right, so we're going to need to work out a lot of things. Yeah, so we're going to pivot around. Don't know actually. I haven't thought about this one. So really, we want expressions for each of their weights, don't we? And Robert's what's stopping it from moving on each one. Cool. Let's just jump in and try it. So if we resolve first of all up and down, I think that's a good place to start. So if we resolve up, if we name each pivot, then we'll call pivot this one pivot A and this one pivot B. Resolving upwards, then we get RA plus RB equals, because it's an equilibrium, Poppy's weight, which was P, Quentin's weight, which was Q, and Robert, which is AT. So P plus Q plus AT. So by my reckoning, if we can find reaction at A and the reaction at B, we can then get to the equation they want us to get to. So if we resolve about A to start with, so if we resolve clockwise about A, we're going to get clockwise, we're going to get Robert's weight of 80 G times by 2 minus, oh yeah, 80G, sorry. I did that right here, but I didn't. It should also be PG and QG. PG, QG as well. Cool. Right, so 80G times 2 minus Poppy's Poppy's moment, which is going to be anti-clockwise, so that's going to be PG times 3. Should equal 0 because it's not turning around to that point. If it was, Robert would be flying off into the air. I was wondering if we can also get will that second seesaw affect things? I think it probably won't because let's go with this and we'll see what happens. I'm not sure about this, whether we need to include RB and Q as well, though, but we'll just show that, so we'll find out. So we're going to get 160G minus 3PG equals 0. No, this will let me find P. I don't think this is right. Okay. I think we need to include all of our forces in this one. So we get minus 3PG. What else have we got? Well, we got RB acting. How can he put all his weight on both seesaws? Because they're joined, we don't know that there's half on each. So I'm going to pretend that both seesaws are one thing now. I don't think treating this like a seesaw is a good idea. So resolving about A, we're going to get, yeah, what did I say? ATG times 2. Yes. So I'm going clockwise. Okay, so anti-clockwise, we're going to get minus RB times 4. And then Quentin's weight is going to be plus QG times by 7. Cool. So that's all the forces acting around around A even. Cool. Okay. So we're going to get 160G minus 3PG minus 4RB plus 7QG equals 0. Cool, bear with me. We're going to do the same thing now, resolving about B. So it's up to you if you go clockwise or anti-clockwise. I think we'll stay going clockwise. So resolve clockwise about B. So about B, we've got clockwise, we've got Quentin, QG times by 3 QG, minus Robert, so Robert is ATG times by 2, plus RA times by 4, and then minus Poppy PG times 7 equals 0. So I've got 3 equations. I'm basically going to rearrange the two that I put in boxes. Going to rearrange those to get RA and RB. I'm going to sub RA and RB into my first equation. Do some rearranging, and I'm pretty confident we're going to get to the show that. I don't think this is the way they're done in the mark scheme. I don't think this is the most straightforward way, but it's the way that requires the least complicated thought process. So let's clear some space here so I can fit all this together. So let's copy this one down. 3QG minus 160G plus 4RA. That looks rubbish. 4RA minus 7PG equals 0. Cool. Is everyone alright with what we've done so far? Because I know I've been kind of thinking my way through it. This is a tough question. So we're going to rearrange these to get RA and RB equals, and we're going to sub them into the top equation. So rearranging the first one, we're going to get 4RA equals 7PG plus 160G minus 3QG. So then dividing all that by 4, RA is 7PG plus 160G minus 3PG all over 4. And rearranging the other one, we're going to get, I'm going to kind of skip a few steps here just to save space. RB equals 7QG minus 3PG plus 160G all over 4. Actually very similar, isn't it? Okay. We're going to put it all together, so get rid of these. And put it all in, so we get 7PG plus 160G minus 3. I've changed a P into a Q there, that's terrible. 3QG. Ignore that P. That should be Q. Where was I? Divided by 4. Plus RB. So RB is 7QG minus 3PG plus 160G over 4 equals PG plus QG plus ATG. Doesn't look great, but everything's there. Everything's in the right kind of position. So let's times both sides by 4 to get rid of the 4. And then we can start straightening up some of the numerator there as well. So I'm going to just do that. I'm going to just get rid of the 4s. Put a big 4 over here in brackets. I don't want to deal with that yet. So let's get my head out of the way. Cool. So we're going to start. We've got 7 PG minus 3 PG, so that gives us 4 PG on the top there. Same with QG, so we've got plus 4 QG. And we got 2 lots of 160G, which is going to be 320G plus 320G. And that should equal 4 PG. Oh no, I see where this is going. This hasn't worked at all, has it? Dear. Oh dear, oh dear. How has that happened? 4PG, 4QG, yeah, and that's going to be 480s is 320G. Oh, I've proved the same thing. No. Okay, this isn't going to work. Damn it. How have we done this? Sorry, guys. I should have done this beforehand. Let's just skip it. No, not happening. Sorry. Never, never skip a question. Okay, so. Okay, I see how they've decided to do this. It's interesting. Okay, so what they've decided to do is to say, we're looking at Robert. Robert has ATG acting down. And Robert is going to have a force up on him from Poppy. And a force up on him from Quentin. And we can balance all of those forces. No, we're not skipping it. So we're balancing the forces on Robert. So we're going to resolve to work out what force is actually acting on Robert from the seesaw, and what force Poppy's part of the seesaw, and what force is acting up on Robert from Quentin's part of the seesaw. So basically, yeah, because it's in balance, we must have that's about A. We must have the same force. Yes, this is actually quite easy. Same forces on each side. So moments about A. So we're kind of splitting this in the sides. We're imagining that Robert's weight isn't doing anything to the seesaw. He's just basically stopping it. He's basically just stopping it from moving. So Poppy employs a moment of PG times 3, which means that that's a moment of 3 PG Newton meters. That must be the same moment on the other side as well. So Robert's going to feel a force up on him, which will be 3 PG divided by the 2 meters, which is his distance. So moments on Robert will be that turning force, but at a distance of 2, so we need to divide it by 2. So force on it's going to be 3 over 2 PG newtons, because we're dividing by the meters. So we can do the same thing again for the Quentin seesaw. Moments about B. So Quentin gives us a QG times 3, which is 3 QG Newton meters. And that's going to be the force on Robert again, so we can do the same thing and divide that by 2. So force on Robert is 3 over 2 QG newtons. So then if we resolve for Robert, we've got 3 over 2 PG plus 3 over 2 QG minus ATG should equal 0. So I can get rid of all the G's now, and we get 3 over 2P P plus Q equals 80. Times 80 by 2, you get 160. Divide 160 by 3, and we get P plus Q equals 160 over 3. And 160 over 3 is 53.3, which we round up, well, round down to 53. So yeah, to the nearest whole number, yeah, P plus Q is 53. That wasn't that bad. I made a bit of a mess of that trying to do it my own way. But yeah, everyone okay with that? Does it make sense? So we're doing it we're using the moments to find forces, and the reason is because we're on. I shouldn't have treated it as a rigid beam because it wasn't a rigid beam because it had a joint in the middle. So that's what went wrong there. Everyone right? Cool. Let's move on to the next one. Just gonna check if anybody else is here yet. So we're still missing Sophie and Leo. Are either of you guys out there? No. Okay. Right. What's next? Back to Google Drive. No, lovely. Cool. So we can do both of these. So we have a mass on a inclined slope. And part 1, draw a force diagram showing all the forces acting on the object. Easy peasy. Describe the origin of each force using words. That's fun. Sorry, Sophie, I didn't take you off there. Cool. All right. So forces acting on this object. We've got a reaction force. Actually, let's give you guys a chance to do this because I shouldn't just be doing all of it as examples. So if you guys could give it a go. I'll give you 10 minutes. I know it's worth 15 marks. We'll give you 10 minutes to give it a try on your own. Just because otherwise I'm just going to do a walkthrough and I'd rather you guys do a bit of work as well. So 10 minutes, give it a try. If you do finish it in 10 minutes, which I doubt because it's worth quite a lot of marks, you're welcome to try question 9 as well. So see how you get on. Cool. Right, so let's go through this one. Oh, it's clipped off the picture there slightly. Cool. So draw a force diagram first of all. So we got 3G downwards. It's a rough plane. So we got some. Oh, damn it. 3G downwards. It's a limiting equilibrium. Okay. So friction is all that's going to be keeping it up. And we're going to have R this way. So describe the origin of each force using words. So 3G is due to the mass of the object. So 3G weight due to mass plus gravity. Reaction force due to contact with slope, and friction due to rough slope. Cool. All right. So part B, we're now trying to find mu. So by resolving in two perpendicular directions. So it doesn't say which, so it's up to us. We normally go plane and perpendicular, so let's keep with that. So if we resolve, perpendicular to the plane first of all, we get R minus 3G cos theta equals 0. So R equals 3G cos theta. So F equals mu 3G cos theta. Now if we resolve down the slope, we're going to get 3G sine theta minus mu 3G cos theta equals 0. So I can divide both sides by, divide everything by 3G. And we're going to get mu equals tan theta. Cool, there we go. That was a nice 6 marks, wasn't it? Cool. Okay, determine whether or not the object slips if mu is 0.3 and theta is 30. Okay, so we need to look back at resolving down the slope. So we're looking at this equation here with all the g's back in it. So we're going to say it'll slip down the slope if the forces down the slope are bigger than the forces up the slope. So if we work out this bit, if 3G sine theta is bigger than mu 3G cos theta, it will go down the slope. So let's put some values in. So we get 3G sine 30. Sine 30 is a half, so we get 3 over 2G. And for the other bit, we get 0.3 times 3G cos 30. So I'll work the two out. I got a feeling it is going to slip down the slope, but we'll see. 0.3 times 3 times 9.8 times cos 30 gives me 7.638. 3 over 2G is 14.7. So yeah, it is going to slip down the slope with some acceleration. So yes, it does. Okay, as theta approaches 90, state whether an object of any mass could remain in equilibrium. No, because you can see why if we sketch cosine. Cos of 90 is 0. So as theta goes to 90, cos of theta goes to 0, therefore no friction, therefore no resistance. to motion. So that would be y, yeah. Cool. Everyone okay? I mean, if you increased mu to 1, I don't know. 1 times 0 is still 0, but 1 times something small, yeah, you might resist a bit of motion, but probably not all of that. Okay, everyone okay with that? All right, let's move on to the next one. It'd be nice if we could finish this today. I don't know how many questions are left, but we'll see. That was 2 big mechanics questions in a row, I guess. Okay, projectiles. This one doesn't look too bad. So 8 marks. I'll give you guys 8 minutes to do it. Write your answers in the chat when you're done. See if you can get this one finished in the time though. Yeah, sounds good to me. Cool. Cool. Yes, well done, you guys that got an answer in that time. Let's do a quick sketch of what's going on. So you've got initial velocity of 8 at an angle of 60. We want to find how long this particle is above 2 meters. So everything we do here is looking at the vertical regime of things. Cool. So resolving vertically then, we got s equals ut plus half at squared. S we know is 2. U is going to be 8 sine 60 times t minus 4.9 t squared. So if we solve that quadratic, we get t is 0.404 or t is 1.009. And the time it's above that point is the difference between those two times. So we subtract those and we get time is 0.6054, which you can round up to 6.1 if you like. So nice, easy 8 marks there. That took me minutes to work out. Yeah, so nice. easy question there. Well done, Fifi. Good job. Right, let's move on. So, question 10. We might finish. I don't want to get my hopes up, but we might actually finish before the end of the week. That'd be really good, especially considering we missed Monday. So, all right, let's try. We'll just do 10, and we'll try and squeeze 11 in at the end. All right, so it's 13 marks. I don't really want to give you guys 13 minutes because that'll be the end of the lecture. I would like to get 2 of these done. So let's give you. Ooh, um, give you 5 minutes. I reckon you guys can do this. They seem to have over calculated the times needed on this test. So 5 minutes. Give it a go. I'll be back in 5 and we'll go through it. So bit forces and looks like a bit of Suvat as well there. It's not actually very clear this. B is I. There, I don't like how they've made that capital I, so I'm going to change it. B is capital I. Newtons. So there's not a 1, it's an I. Sorry, guys. Yeah, so we got two forces acting on a particle, and we know sum of F equals ma. So if we sum our forces, that should be equal to the mass of the particle times the acceleration. Find the acceleration, and then use that to find its displacement. Cool. So sum the forces, and we get 3 minus 1 equals 0.5a. So if we times those by 2, we get a is 6 minus 2 meters per second squared. Cool. All right, so we're going to use this. We know it starts from rest, so we know u equals 0. And we know the particle starts at 3, 4. So we're going to keep that for in a minute. So we want to find how much it... Oh, x and y... Oh, okay, right, fine. Let me get rid of what we've done so far. Cool. Okay. I've got the wrong idea here. Right, we are going to integrate our acceleration. To remember, integral of acceleration is velocity. Integral of velocity is displacement. So if we integrate 6i minus 2j with respect to t, we're going to get 6ti minus 2tj plus c, and that's going to be our velocity as a vector. And we know it's at rest initially, so we know when t is 0, v is 0, therefore c is 0. Cool. Same thing, we're now going to integrate that to find our displacement. So s is the integral of 6ti minus 2tj, which gives me 6t squared over 2, so that's going to be 3t squared I. And then we're going to get minus t squared j plus c. So that is my displacement equation. S 3t squared I minus t squared j plus c. And we know initially, when t is 0, the displacement or the position S is 3, 4. So I can put that in and we get S equals 3t squared plus 3i, and then minus t squared plus 4j. And that's our position at any time for that particle. Cool. Just checking that's right. I'm pretty sure it is. Yeah, cool. So the x and y coordinates here, if you wanted to put them as coordinates, you could do x equals that and y equals that, but I think it's the same thing. Right, explain why it never returns to its starting point. That's really sad, isn't it? So why does it never return? Well, we came up with it's never decelerating in the x direction, so it's never going to return anywhere. We could also say 3t plus 3, 3t squared plus 3 is x. 3t squared plus 3 will never equal 3 after t equals 0, because it's never going to go back. Never going to go back to that point. So you could plot it as well if you wanted. We got a quadratic moved up 3. This is x. This is t. We can see it never returns to where it started. So that's why. Yeah. So any kind of reasoning there. So you could say it never. Yeah, I know it starts at 3, 4. Did I No, I haven't done anything with that. Yeah, I mean, you could look at y as well. You could say, well, y is 4 minus t squared. Again, y is never going to get back to, if you plot y against t, you got minus quadratic plus 4. So you've got this. That's never going to equal 4 again. It's just going to go off. So yeah, sadly, it's never going to get back to where it used to be. And you could explain that for x or y. As long as you had a sketch or some kind of reasoning, you'd get away with that. Okay, describe a physical situation. Describe a physical situation which this model can represent. Ooh, that's interesting. That's yeah. What have you guys got? Let's see what you come up with. I'm just thinking of rockets, but that's me, isn't it? Um, what physical situations could represent something that looks like that? Any ideas? So what do we have again? I'll just write down the equations. The x coordinates are 3 plus 3t squared, and the y coordinates is 4 minus t squared. So its x values are increasing. Its y values are decreasing. Well, the y position is decreasing. Remember the acceleration was what did we say it was again? I wish I hadn't got rid of it. Was it? Was it? That would be 3 minus 1. So I think it was 6 minus 2. So it's accelerating in one direction and decelerating in the other direction. See if you guys can think of any situations that might represent that. So I give you 2 minutes to have a think. See if you can type your responses. Callum, that doesn't count because that's the one it says in the mark scheme, so no marks for your boat and your river. Cool. Any ideas then? So we need a constant force accelerating in one direction. A car cross. Stop doing river things. How's the car gonna work? I can see the car crossing the river. I guess yeah, friction and deceleration on the King Harry Ferry. Nice. Um, yeah, anything where you've got something accelerating in one direction but slowing down in the other direction. you know, there's millions of things you come up with. A car driving down a road with a crosswind would do that. You know, you're accelerating forwards, but you're being pushed to the side. Yeah, just any situation where you got one acceleration in one direction and one deceleration in the other. Okay, last question. If we don't finish this today, I will get you guys doing it for homework. Oh, it's a nice astrophysics question. Wicked. So, position of a planet orbiting a star is given by that equation. Find the velocity and acceleration of the planet in terms of t. This shouldn't take long, but yeah. So I'm gonna set this one for you guys. You can start it now. I'll stay here and see if you need any Caleb trying to run parachute. Yeah, maybe. Yeah. See if you guys can do this one. If not, I want you to do this for Monday, and we'll go through it then. And remember, you got your test coming up, so get revising. Yeah. Cool. Right. So start it now. I will stay here. Has anyone got any questions though? Anyone questions? Have a read through this, copy it down, then I'll leave you to it. No questions. Cool. Right. I'll leave that for today then, guys. So we'll do this one on Monday. And then we'll start looking at a pure paper. So going to be revising pure next week. Right. Have a good weekend, guys, and I will see you then.